Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
Forces. What is a force? A force could be a push. A force could be a pull. Write this down. A force is a push or pull exerted on matter. A force is a push or pull exerted on matter. A force can cause an object to do three things. A force can cause an object to do three things. It can start an object moving, it can stop an object from moving, or it can change the direction of an object. So a force can do three things: start an object moving, stop an object moving, or change the direction of an object. So gravity is an example of a force. You need to know that gravity is a force that pulls all objects towards the earth. When you drop a ball, it falls to the ground. That is because the force of gravity. Something is pulling that ball towards the earth. Gravity is a force working on all objects on earth. Pushing a cart up a hill is another example of a force. When you push a cart up a hill, it might be a little more difficult because you are applying a force against the cart. You are not only working against the force of gravity, but you're also working against the force of friction. Take note that friction is a force acting in the opposite direction of motion. Friction is a force acting in the opposite direction of motion. Friction occurs when two objects are in contact with each other. Therefore, pushing furniture on an old rough carpet might be difficult because there is that force working against you, the friction of the moving furniture on that rough carpet. Imagine pushing the same furniture on one of those smooth linoleum floors. It'd be much easier, right? There's still friction, it's just less friction. Another simple way to illustrate a force is a textbook resting on a desk, probably like your textbook right now. It may seem that there aren't any forces acting on this book, but gravity is actually forcing the book down while the table is forcing the book up. Now that we know some examples of forces, we can discuss how forces affect motion. You need to know that forces acting on objects occur in pairs, are balanced or unbalanced, and have magnitude and direction. You need to know that forces acting on objects occur in pairs, are balanced or unbalanced, and have magnitude and direction. You must also know that when a pair of forces have equal strength and act in opposite directions, they are balanced forces. When a pair of forces have equal strength and act in opposite directions, we say they are balanced forces. When we mention the strength of a force, we're referring to its magnitude. You want to write this down. The magnitude of a force is the difference between all the forces acting on the object. The magnitude of the force is the difference between all forces acting on that object. We measure force in newtons because Isaac Newton's work on forces. It would be kind of like if you and I were pushing a box towards each other. The direction of the forces in this case would be towards each other, and basically the magnitude is the size of the force we are using to push the book against each other. You must remember that the direction is the way the force and our object is moving. So the direction is the way the force or object is moving, left, right, up, or down. So let's try an example. If I push a box with 3 newtons of force to the right, and you push the box to the left with 3 newtons, the forces would cancel out. The book wouldn't move. So the difference between the forces is 0. The magnitude acting on the books is 0. The word difference means subtract. Therefore, the forces cancel each other out, and the motion they are acting on is unchanged. The box wasn't moving, and it still isn't moving. 3 newtons minus 3 newtons is 0. You must also know that when one of the forces in a pair is greater than the other, they are considered unbalanced forces. When one of the forces in the pair is greater than the other, they are considered unbalanced forces. Write this down too. An unbalanced force results in a change of motion. An unbalanced force results in change in motion. So for example, when an unbalanced force acts on an object at rest, the object will begin to move. So, what happens to the box when I apply greater force in one direction? So I'm going to apply greater force to this box to the right. The box changes its motion. So if I am pushing on the box with 5 newtons of force to the right, and you're pushing on the box with 3 newtons to the left, which way will the box move? And what will be the magnitude? Let's solve this problem. 5 newtons to the right minus 3 newtons to the left, we have a magnitude of 2 newtons. The box will move to the right. So don't forget, an unbalanced force causes an object to stop moving, change direction, or change speed. Stop moving, change direction, or change speed. Let's review. When dealing with balanced forces, the motion of the object doesn't change. Forces are equal in size, and the forces move in opposite directions. When dealing with unbalanced forces, the motion of the object changes speed or direction, and the forces are unequal in size. And lastly, examples of forces might include gravity and friction, and both of these forces push and pull. This is the end of our lecture on balanced and unbalanced forces.